Hey, what's up? Ooh, how long has it been since I actually decided I wanted to write code live on the internet? Let me turn down the music from my view. I will also turn down Spotify view from there. Oh, it has been... God, it's been too long. And I've had the itch for quite a while. Some of you may have remembered seeing me give it the good college try, trying out Path of Exile after they had just announced their new little season. And that was fun. It was. I enjoyed it up until I want to say, oh, I forget it was what's the final act? Like Act 10? Where you realize you're really just going through the same area the third time. And then it becomes just optimization from there. Let me see if I can... I'm noticing I seem to be peaking a little bit with my mic. Let's turn down the gain just a little bit, down to 12 decibels. I'm still going to be... It's almost like I used to be a streamer. There we go. Let's try not to blow out any eardrums, shall we? But it has been a hot minute since I've done anything. Since I've really felt like I've done anything around here. Let me see if I can get a hold of who I'm allowed to bother about this. I feel like it's a little bit of a return because I do want to make commitments. I want to try to commit to this idea. Let me see, just a second. But yeah, it has... I think it's been long overdue. I've spent some time going over, I probably spent too much time going over, what do I want this whole operation to even look like? What does it look like in my grand design? What do I want to do with this? And, I really did want to get back to writing software, and there's a let's see if we can go to the chatting section, and just to make sure, is oh, my YouTube stream is still under unlisted. Let's see if we can change that. Where is visibility on here? Visibility public. There we go. So yeah, let's chat check Twitch. Oh, hello. There's the chat. Can it detect the other platforms? Not quite. Okay. We're still making sure everything works properly. It's been a minute, and after watching so much of the recent uprising of live coding channels, not just live coding, but people who are like proper software engineers, more than I ended up being. And really actually making it and making good stuff and putting it out there. People like Primeagen, people like Low Level Learning, especially Low Level Learning, considering like I started out trying to be a hardware developer. If any of you remember those days. Low Level Learning, doing embedded systems, that was always a big thing. Oh, let me just turn that off. Low Level Learning was a big inspiration, and I guess the big one that you always have to mention is Pirate Software, right? Because he's the one that basically almost entirely took over Shorts, the Shorts part of the platform. And so he is just absolutely crushing it. And, you know, I got to thinking, I started thinking more about where my career is at now and where I would like it to be. And, you know, I really like the idea of trying to make a return and using it as an opportunity to learn more, to get back into what I really enjoyed, which was, you know, open source software and developing and building things. I tried doing a couple gaming streams. They didn't quite work out as well as I'd hoped. Not just from metrics are going to be awful. Like, I'm going to have basically 0 viewers for the foreseeable future. For quite a while. Like, right? It's a thing. But the gaming streams kind of didn't feel right. Final Fantasy XIV, I wasn't finding as a good experience to try and make content out of, and Path of Exile also wasn't working out, but I feel like maybe I can give this a shot. And even though I'm diving into a subject I know so very little about, and that's going to be the Rust programming language, and I'm gonna start probably with a rather difficult subject with asynchronous programming using the Tokio. I think they call it a crate. I think they call it an executor. But all kinds of things that are going to be really weird, but they should still be fun, I hope. Let me see if I can... There we go. But yeah, it's... I hope I'm jumping back in the saddle. I'm hoping that I can try and commit to being something, to doing things with this platform that I never had before. And I'd like to continue on this path. And anyone who happens to hop on, I hope you stick around with me. So let me go ahead and start. Let's go back over to... Let's debut the new development area. This was actually quite fun to build. Let's see if I can move this over. So here I have all of my... I'm in my dev/Rust folder, and I already have a Learn Tokio folder set up. Let's see if I can Learn Tokio. So cargo, new. Well, let's not worry about that too much right now, because one thing that I found fun, and I would just like to point it out. I really like this idea that I could set up a transparent background for my development environment. And, you know, Primeagen was able to set that up, and he had a video where he did that with his development environment, and he shows a static background. I wanted to just see if I can one-up that in a way that is fun visually but not distracting, so hence the animated background you see before you. And It's probably going to be way too distracting. It's probably going to be way too much. But I wanted to give it a shot. And I spent a lot of time on that. Again, probably way too much. But you know what? Why not? Let's keep running with it, all right? But the big thing is I'd like to see where we can go with this language called Rust. Very low level, very, not quite Python, where Python was always built to be a language you can build something and make it easy to understand and easy to read because you can almost basically just write pseudocode and have it just work. And that's always been something that really entranced. Entranced, is that a word? It really something that attracted me to Python as a programming language. It's like it's easy to get into. Rust seems like it has a little bit more of a curve, a little bit more of a difficulty spike, but allows still a very powerful language, and it's even low level like C. If you remember back when I was doing embedded system stuff, I was doing a lot of C. So for now, let's just grab, which window is this? Okay, yes, that's the correct window. So let's slide that right in. So what they're saying is Tokio, asynchronous runtime for the Rust programming language, provides the building blocks needed for writing networking applications. Some of you may, if you've been around me for the past couple months, there's always been this project that's gone on in my mind, and I do mean months. I don't mean years. If you've been with me for years, you know there's one project in particular. I do want to get to that, but I've also got a new thing that I've been thinking about for quite the hot minute. Anyway, when I see networking, and I'm thinking, there's several, let's say, networks that I'm practically a part of right now that I'd really like to see if I can network them together, let's say. I'm just gonna go ahead. So, asynchronous runtime for the Rust language. At high level, Tokio provides a few major components. A multi-threaded runtime for executing asynchronous code, and an asynchronous version of the standard library. That's actually quite interesting. So they took the Rust standard library and they made it async. That could prove useful. Considering I'm not even all that familiar with the Rust standard library at all, that could be a challenge, but we're up for challenges, right? Aren't we? And a large ecosystem of libraries. So, Tokio's role in your project. Writing an application in an asynchronous manner, you enable it to scale much better by reducing the cost of doing many things at the same time. However, asynchronous Rust code does not run on its own. You must choose a... Oh, hang on. I should probably... There we go. Asynchronous Rust code does not run on its own. You must choose a runtime to execute it. Tokio Library is the most widely used runtime, surpassing all other runtimes in usage combined. Additionally, Tokio provides many useful utilities. When writing asynchronous code, you cannot use the ordinary... Ooh, excuse me. It has been a while. It's straining my voice and getting a little burpy there. Additionally, Tokio provides many useful utilities. When writing asynchronous code, you cannot... That's actually... When writing asynchronous code, you cannot use the ordinary blocking APIs and must use asynchronous versions of them. These alternate versions are provided by Tokio, mirroring mirroring the API of the Rust standard library where it makes sense. What are the advantages? Fast. Tokyo is fast. In italics, it is fast. Built on top of the Rust language, which itself is fast. This is done in the spirit of Rust with the goal that you should not be able to improve the performance by writing equivalent code by hand. It is scalable. Scalable in italics. They want to put emphasis there. Built on top of the... Oh, it's built on top of the async await language feature. So there already is async await inside the Rust language, which itself is scalable. When dealing with networking, there's a limit to how fast you can handle a connection due to latency. So the only way to scale is to handle many connections at once. With the async/await language feature, increasing the number of concurrent operations becomes incredibly cheap, allowing you to scale to a large number of concurrent tasks. I can think of a couple. I can think of several tasks that I'd like to build on top of. Tokyo is built using Rust, a language that empowers everyone to build reliable and efficient software. Okay. A number of studies, those are tabs that we can open later. 70% of high severity security bugs are the result of memory unsafety. Has anyone read that White House press document? Mickey UK_dev. Hello, how are you? Welcome aboard. Do you mind if I ask where you're coming from and where you might have found my little hole of the internet? But yeah, welcome in. Jump on board and enjoy the ride. Either way. Providing consistent behavior with no surprises. That's a good goal to strive for. Major goal is to allow users to deploy predictable software that performs the same day in and day out. With Rust's async await feature, the complexity of writing asynchronous applications has been lowered substantially. Paired with Tokyo's utilities and vibrant ecosystem, writing applications is a breeze. Procrastinating, snooping on devs. Oh, are you spying? You over here spying? Should I put chat? I should probably put chat above the... There we go. I'll put chat above the browser window. So we have a spy in here, ladies and gentlemen. So what would you be procrastinating on? What is it that you should be doing instead of putting your eyeballs on me? If I might be so bold as to ask. Let's see, flexible. Getting back to the document here. Flexibility. Multiple variations of the runtime. Everything from a multi-threaded work stealing. I don't know what work stealing means. Work stealing. Let's zoom in on that a little bit. Parallel computing is a scheduling strategy for multi-threaded programs. Executing a dynamically. Should be finishing a project, but burnt out. Learning Rust, eh? Yes, in fact I am. Well, I'm at least saying I should be learning Rust, right? I come from a background in... At first I was doing embedded systems. That's what my education's in. Doing a lot of C. Eventually I started doing a lot of Python, and I did a lot of Python here on... looks like you found me on Twitch. I'm now also on YouTube and Kick. Did a lot of Python, and I feel like Rust is at a place where... Like, I'm starting to hear Rust spoken about in ways that make me think, oh, someone's... You know, I used to hear Rust and immediately think, oh, someone's just trying to like, shill their pet project, right? Oh, Rust is some pet language. And it sounds like Rust is at a place where, okay, let's see if I can take this seriously. And, you know, but you kind of have to treat almost every time someone says, hey, I'm going to make a new programming language, you have to kind of treat it as, this is probably somebody's pet. Nothing real is going to come of it. Like, because how many times if you're in the JavaScript world, how many times have people really tried to replace React? And we've maybe actually gotten 2 or 3 two or three like real attempts that I've gotten anywhere with doing the work that React does. Learning a bit of Rust for my project, it's quite difficult to get a handle on it. Yeah, I will admit to saying that. I will admit to saying that I've done a little bit of Rust. I have some. I've worked my way through a little bit of the Rust book. There's what do they call it? The Rustlings? Is it Rustlings? Small exercises. I did a little bit of the Rustlings stuff to kind of familiarize myself with what's going on, and it is just like you said, you're correct. It is kind of weird to get your head around. There was a channel called Let's Get Rusty, a YouTube channel called Let's Get Rusty that helped me that I think helped me grasp the concept of ownership and lifetimes and borrowing. Those are the two things that are like, that is really weird. Let's see, what is it? Rust Survival Guide. Is this the one? Ownership. Yeah, this is the video that helped me. Those are the. I'll link it there in chat. So that video there really did like, it got me to a place where I feel like I can understand ownership, borrowing, and the lifetime stuff, which to me felt like the big problem. Not problem, but the big issue to get my head wrapped around. So now what I'm doing is I'm trying to tackle both that. Maybe I'm biting off more than I can chew, but you know what? You never know until you try. So I'm also working on wrapping my head around asynchronous programming, which like asynchronous programming just in general, rather than multi-threading, which is also kind of a bugbear to tackle. But yeah, welcome in. You're gonna check. I mean, like, hey, I'd appreciate it if you kept watching me, because you know, shouldn't have told you to go watch someone else while I'm here streaming. But hey, you know what? Maybe I'm a bad streamer. So let's see when not to. Actually, that's actually a good. I like it when you see a section like that says when not to do our thing. So when does he say, although Tokio is useful for many projects that need to do a lot of things simultaneously, there are also some use cases where Tokio is not a good fit. Speeding up CPU-bound computations by running them in parallel or on several threads. Let me see. Actually, let me check one real quick. Something just randomly on my mind I wanted to look into. Okay, yes. Good. That is good to know. I wanted to check to see if my YouTube chat also is embedded in this system. I don't think Kick is, but Twitch and YouTube should both be appearing over here on the right side. Speeding up CPU-bound. Back to the document. Speeding up CPU-bound documentation by running them in parallel on several threads. Tokio is designed for I/O-bound applications, where each individual task spends most of its time waiting for I/O. Now, that's actually an interesting question, right? If it's I/O bound, is a good use case more event based rather than just I/O? I've been using AIs to get quick answers. Often takes down a rabbit hole. Oh yeah, I've run into my fair share of rabbit holes. Just any kind of project, like, oh shit, I need to take on a lot of information at once, and then you realize, oh, what's the shiny thing over there? What's this language do? Or what's this library do? So Tokio is designed for IO-bound applications. So does IO-bound, I feel like I should actually know this, but does IO-bound go hand in hand with event-based? Where, because immediately you think of the biggest use case, you know, sending us, and here's the third thing, is sending a single web request. The question becomes, instead of web-based requests, telling me I need to use Tokio, not find it, only Tokio_util. Okay. Yeah, that's where I would be under several circumstances real careful about using AI for programming stuff. But like I don't do it myself, and I've got several friends who say that AI at some point just starts making things up. So I would be careful. I don't know if just like, what AI are you using? I assume just like everybody else, you're using Copilot. See, I personally have not touched Copilot, but I've seen people say they swear by it, and then I have people say at some point it just makes things up. And like probably the real answer between the two is you're not really spending less time programming, because any time you would spend writing that solution yourself is now going to be spent auditing what the AI spits out to make sure that the AI is not spitting out just complete garbage. It's particularly bad with high-level languages like Rust. I don't know that you'd say Rust is particularly high-level. C++, and I turned Copilot off for that as it spat out garbage. Okay. Oh, so C++. So, are you a student or are you a professional developer? Mind if I ask, what's your story? Place where or like a home developer or independent? So anyway, back to the document. Tokio, useful project to simply read a lot of files. Tokio provides no advantage compared to an ordinary thread. Operating systems generally do not provide asynchronous file API. Good point. Sending professional web developer, but you have a few open source projects. Okay. So when I was saying, like, yeah, in the JavaScript world, there have been several attempts to replace React at this point, as far as like the big popular framework, but the hotness has been React for a while, even though Angular, is it Angular, I think, that's still 80% of websites now? So sending a single web request, the place where Tokio gives you an advantage is when you need to do many things at the same time. If you need to use a library intended for asynchronous Rust, such as requests, but you don't need to do a lot of things at once, you should prefer the blocking version of that library. So I imagine for the project I have in mind, which I'm not going to say just yet, but friends of mine who have been around for a while should know that I have a project in mind, especially related to streaming, that we'll be using a lot of. Recently started using Vue. Okay, so you're a man after my own heart. Whenever I had web projects, I really fell in love with Vue. Admittedly, mostly out of syntax. I'm not a good enough developer to like really get into the deep of like, here's these language features, and like this one does multi-threading really well. This one does sockets really well. I'm not good enough of a engineer and developer to be able to drill down into that difference. But I can say with certainty that I really fell in love with at least the Vue syntax because it reminded me very much of like, this looks like HTML. This looks like when I was writing HTML web pages when I was 15 years old on GeoCities. It just looks familiar. It felt like I was writing web stuff. I fell into Rust using a framework called Tori. Okay, yeah, I know about Tori. And on setup, it recommended you use Vue and Rust with it. Wait. So you sound like someone who wanted to build a desktop app, but really didn't want to get into Electron? On setup, it recommended you use Vue and Rust with it. So, and Rust with it. That feels like a weird statement, because Rust is, I mean, a Tori is Electron but Rust. If you want to create a desktop app, hi, Tasty. Is it Tasty T Dev? Tasty T Dev. Don't use Tori. Now why? Yeah, I think Mickey has a proper question. Why? How come? Why would you not want to use Tori? My assumption. I would not want to use a web framework to build out a desktop application. I maybe I'm old school. Maybe I'm an old curmudgeon. But the idea of writing my application's front end in HTML when it's meant to run on the desktop. Iced RS. Let's actually look that up. Iced RS. Iced RS. Let's see, what's going on here? Cross-platform GUI library, inspired by Elm. Batteries included API, cross-platform, that's good. Built-in widgets. So is this meant to be? So so here's the thing. I haven't actually written any desktop applications. I've written web applications. I come from the world where I was writing web applications in Flask. I wanted to try and break into doing a desktop application, and in fact, my current project is, I have grand designs that it'll be a desktop application. It started life as a Python project, and I was using tk-enter. Front-end web dev. Best solution right now. Okay. So is this more familiar? So this uses a little bit more native desktop. This uses a little bit more of a native desktop kind of the APIs that you're used to, like I want to say like Qt and like TK and maybe like GTK. It's more in that realm rather than embedding a web browser and you just render JavaScript and HTML and CSS. WebRTC app, not the most amazing. Well, hey, you fit right in here because I'm a goddamn idiot. So I made a prototype in Electron, but it ran slow. Tori sounded good because I found a lot of posts. So yeah, I think that's where a lot of people, because Tori is going to be the solution for, like, hey, I'm a web designer and I wanted to write an actual desktop app. And so that seems like the easy way to go. Is only usage of system web view instead of a separate application. So like where Electron is rendering an actual, so you don't want to use HTML, CSS, and JavaScript as a front end for a desktop app at all. So you're kind of in my boat, it sounds like, Tasty T. Electron, Tauri. So, okay, all of that, just throw it out. You just rather use something that uses more native system graphics application APIs. Because I also wanted to break into, because where I come from in Python, there's tkinter, There's Qt. Qt if you're a C++ guy. Also in Python. But yeah, that's definitely a goal. Is I'd like it to be cross-platform, but not use web stuff. But maybe it needs to use web stuff. TypeScript and C#. Okay. I will definitely keep an eye on Iced. Because there was, when I was looking into it, enter Rust. I know it's not GUI multi-platform. Users wrestling. Okay, this guy said Ice. What was the one? There was another one that I found. I hope I will be a Rust guy soon. You know what? I hope I will be a Rust guy soon. I think we're in the same boat. We can figure this out together. Why is okay? I need to do something real quick. Inspect? No? Hang on. Can I add? No, I guess I cannot. So let's go back to Rust GUI library TK. Rust TK. Is that what I'm looking at? Rust TK? Lane. I'm clicking on links that are very dangerous at this point. I have no idea where I'm going. A Rust binding to the TK graphics toolkit. Am I a C++ guy in the past? I would say C++. I was a C guy in the past. My actual education is in embedded systems. Whereas, what is embedded systems? It's, if you've ever programmed an Arduino, or if you've ever done any like robotics stuff, I hesitate to say Raspberry Pi because a lot of people are now using Raspberry Pi for like web apps and servers rather than any kind of like robotics stuff. My education is in embedded systems. I program the computers that a lot of people forget exist. Industrial microcontrollers. Oh, so you know, like, so you probably got a lot of like experience in like the PIC stuff. The actual microchip, or maybe you are an Atmel guy, or maybe you are an STM guy. But yeah, I learned my education. I went to, I won't say the school I went to just yet, but my education, I went through electrical engineering. Got core competency in embedded systems, so I started off as a C guy. Never ended up getting an electrical engineer job, much to my great shame. So I started learning programming through Python. My first big project was a Sparky. Oh, BJ. I forgot how to actually pronounce the name that you have, but BJ, welcome aboard. Happy to have you here. Did Hanny post my stream somewhere? Did Hanny post my stream to you there? Mojo, got it. Did Hanny? Oh, he did not. I guess you're just following me, aren't you? But yeah, you know, I did a lot of Python. I forgot how I met Hanny, but did a lot of Python. Then I learned to do web stuff with Flask. Unfortunately, I still can't sit here and tell you that I'm a professional developer. But you know, I want to get back to it, and probably one of the best ways to get back to it is see what's the new hotness everybody's talking about. What's this new stuff? So I wanted to learn some Rust. But yeah, this is the graphics toolkit that you're a professional developer in a web field. Okay, so we've got two of those. I forget, web apps since 2013. So, what is your usual backend, if I might ask? Because when I was a lot more active trying to do web development, my backend was Flask, with a database controlled via SQL Alchemy. And then I learned Vue to do the front end. Yeah, let's see. Sending a single web request. Place where Tokyo gives you an advantage. when you need to do many things at the same time. So definitely my current project idea. I'm pulling data from many sources. I'm pulling data from Twitch, from YouTube, from Kick, and from Discord. All developers who do commercial apps successfully as a professional developer. Yep. Unfortunately, I still haven't been paid even once to be writing to write software. But, you know, maybe that'll change. Maybe that'll change. English not your native language? You seem plenty understandable to me. I wouldn't worry too much about it. We're all going to be replaced by AI anyway. And it's probably not too far off. I don't know. But who knows? I mean, even you said, Mickey, that C++ AI tools tend to shit out garbage. Tokyo, okay. Don't need to do a lot of things at once. For the blocking version, make your project simpler. Have I completed the Rust book? I can't say I've completed it, but I've done a lot of work, done a lot of stuff in it. And it didn't really, because I mean, at some point, programming is programming, right? And if you're coming from, and it's someone like me and see, it's like, okay, well, a lot of it is syntax. The Rust book didn't really help me all that much in trying to be... Oh, what's the word I'm looking for? The Rust book, there were a lot of concepts that I felt weren't really, like, indicative, or not indicative. What's the word? Like, the big concepts that make Rust difficult weren't really getting attention, it looked like, as I was working my way through Rust. The Rust book looked like it was trying to teach programming and then using Rust to do that. Because I know how to program. I'd like to know, like, okay, what is special about Rust? And a couple of the things that like, what are the, because Rust also comes with a lot of pitfalls, right? Like, that compiler will beat you to death. That compiler will absolutely beat you to death if you don't follow its rules correctly. And the three things that still are tripping me up that I'm gonna see if I can work my way through are: one, why the hell are there 5 different types of strings? Why does string exist as like 5 different types? Now, you think after Rust book completion they'll be ready to create a normal complex app? Probably before. So one of my big inspirations that caused me to get back into streaming rather than just get back into development was seeing Primeagen. If you've heard of him, and his big theory, which, you know, after thinking about, yeah, I really do agree with. Hey, Annie, what's up, man? One of the things that I really agree with that Primeagen says is the best way to learn is to build. Well, no, I disagree slightly. The best way to learn is to teach. The absolute best way to learn is to teach. I disagree with him on that, but then he says, cannot parse my speech so fast. Okay. One of the things that this creator called the Primeagen says is, he says that the best way to learn is to build. I partially agree with that. Personally, I think the actual best way to learn is to teach. But I won't get into that. But a really good way to learn is to build. Which is, going through a tutorial can only help so much. And Hannylicious here can say, hey, without it, theory will be theory will be forgotten. Yes. If you've ever heard of something called tutorial hell, it's a concept where everyone says like, "Oh, once you've read this book, once you've gone through this tutorial, and here I am going through a tutorial on Tokyo, you haven't really learned anything here, right?" Usually what I'm doing with this tutorial is I'm going to see if I can get the basics both of Tokyo itself and of asynchronous programming. Because that's a little bit of a tackle. What is Tokyo? Well, it's a good thing I have this pulled up right here, Hanny. Tokyo is an asynchronous runtime for Rust, the Rust programming language. It provides the building blocks needed for writing networking applications. It gives the flexibility. So basically, it is a library, just like Async.io. You're the other Python guy here. It's async. Tokyo is one of the many versions of Async.io, but Rust. But it's not merely one of many. Everywhere I go that say, if I want to do async Rust, what do I use? And number one with a bullet and a power gap is always Tokyo. Whereas, Python is number one with a bullet and a power gap is Async.io. So, let's say easy. Async await feature, complexity of writing asynchronous. Why do I need Tokyo to do async operations? So, supposedly, you actually don't. Supposedly, the standard library has async await at the very least. Where is it? Tokyo's built using Rust. So, Rust actually does have async await. Supposedly, Tokyo. I wish I had a good answer for that question, Tasty. But right now, I don't actually have that answer for you. Everyone has. It's basically. I can't answer why it's the one that everyone suggests, but it is. If you want to do async await, you should probably use Tokyo. And there's no. I don't have it. I don't have. As far as why, I couldn't tell you. Mojo has used his points to redeem some of my old emotes. Oh man, seeing my emotes get used. It's been a while, hasn't it? Oh man, that takes me back. I should probably upload those emotes to the YouTube channel. By the way, probably shouldn't say this because Twitch. You will ask your Twitch mentor on it. Okay. When you say Twitch mentor, do you mean a Twitch employee or that you know of? Or or just another, or are you speaking on he's just another streamer in Rust? Okay. With complexity has been lowered substantially paired with Tokyo's utilities, and you know what? I think this actually might answer your question here, this paragraph. With Rust's async await feature, the complexity of writing asynchronous applications has been lowered substantially. Paired with Tokyo's utilities and vibrant ecosystem, writing applications is a breeze. Okay. Follows the standard, so it replaces a lot of the standard library, it looks like, or at least provides alternatives that are built to be asynchronous. Whereas I don't know if the Rust standard library provides a lot of these tools. That's what I assume anyway. So, just a second. Yeah, Henny, I think I'm in that same boat, because it sounds like it's a lot of cleanup and ease of use, like quality of life stuff. So if at any point, you can always get help on Discord. By the way, if you want to join my Discord, I just did a lot of... seems like the pause I would make... Which... Oh no, that pause was just, I was feeling a little uncomfortable and I wanted to readjust in my chair. But it squeaks and I don't like hearing that squeak in my own mic. And I'm also single, so there is that. Oh, where am I? What am I lost my train of thought. Syntax sugar around async and wait. That's not impossible. That is a distinct possibility. But let's see. I think we've been spending plenty of time on that. Let's see setup. Marriage is hard. You gotta get there too. Anyways, this tutorial will take us step by step through the process of building a Redis client and server. Okay. We'll start with the basics of async programming with Rust and build up from there. Implement a subset of Redis commands, but we'll get a comprehensive tour of Tokyo. Okay. This project that you will build in this tutorial is available as mini Redis on GitHub. So are you what? You're also married? Or you got... I got you pumped, huh? Oh man, it is a slightly weird experience to be back. Gotta say. And just to actually see people showing up. Like, not just showing up and watching, but chatting as well. I gotta say, I really appreciate being able to bounce off of some people in chat for my first stream back, actually doing. Well, I haven't done any programming yet, but we'll see where I get as we go along. Let's see. Need to go read Rust book. I don't want to read about Tokyo before Rust basics. Well, I mean, like, do we want to switch to the Rust book? I mean, the Rust book... yeah, to me, it felt like the Rust book was trying to teach programming first, and then using Rust to do it, rather than teaching Rust. If that makes sense. In fact, I think I said that. Because the stuff that makes Rust special, not just special, but the stuff that makes Rust weird, I would like to have a little bit more. I'd like to have a little bit more insight into that. Have you heard of Lobster? I have not. Should I be? Is that something I can Google safely? By the way, Tasty Tea, but see you around. Actually, before you go, if I can shill my Discord, I'd love to have you as part of the bigger community I'm trying to build. So if you go to discord.amperature.com, you will see a link to an invite to my Discord. And we can talk further after, once the stream here is done. So this is actually interesting. Project that you will build in this tutorial available as Mini Redis. Mini Redis is designed with the primary goal of learning Tokyo, and is therefore very well commented. But this also means that Mini Redis, talking crustacean related. Oh, okay. Lobster. Let me see if I can I Google that safely? Lobster programming. Tries to combine the advantages of static typing and compile time memory management. Tar syntax. Is this like this feels like somebody's pet project language, which I said the same about Rust years ago. Mystic, how have you been, man? I've been For a fat minute, I've had the itch to come back and start doing development again. I've been really wanting to. Didn't know if I could. Didn't know if it would be useful to anybody. Didn't know if I would enjoy it anymore. And I wanted to get back to development. So far, my first stream back seems like a good time. Why not? But how have you been, Mystic? Have you been last time we talked, I think you were still working on trying to get a development job, right? Or trying to do like a web development stuff? I don't know if you've got any updates on that front. Tutorial takes step by step. Building a Redis client and building a Redis server. That's actually really interesting. We will start with the basics of async programming with Rust and build up from there. Implement a subset of Redis commands, but we'll get a comprehensive tour of Tokyo. Currently out of my depth, and you're gonna go get ready for bed. Am I diving too deep already? I'm already driving people away. But nah, don't worry. I'm not too worried about it. If we enjoy challenges around here, don't we? But yeah, thank you, Mojo. Enjoy your sleep. I know it's probably late over there. I don't know where you are actually from. But yeah, let's... What time is it, actually? Oh, it's only 9 here, so I'm not too worried. And, see, that's awesome. Been good. Bootcamp course for React, Node, and Express. Past 5 to 6 weeks, relearning HTML. That's good. CSS and JavaScript stuff, especially JS functions, methods, and etc. You know what, Mystic? By the way, Mojo, sorry, I'm trying to maintain several conversations at once. It's almost like I used to do this as a streamer, and it's almost like I used to maybe be good at it. Mojo, I really hope you have a good night. Thank you for stopping by. I do appreciate it. I do have a link to my own Discord, but I will probably see you in Hanny's Discord. Mystic, it's really good to see that you're picking web development back up. If you're doing a boot camp, like how far are you into that? You know what? If you're learning CSS, someone you might actually get a hold of for that is Hanny. He would love to tell. I'm sure Hanny would love to tell you all about a special library called Tailwind CSS. You know, because I've heard that he just absolutely loves this stuff. Just running with Tailwind is seems to be his specialty. I'm memeing on Hanny. I will say, Hanny, I swear I've heard you talk about, like, whenever I said we talked at some point about doing web stuff, and then I asked about what when you first introduced HTMX to me. You told me about HTMX, and then as an attachment to that, you said you would probably do your next project in HTMX with Tailwind. I would swear to you, that's what I heard out of you. But you're still denying it, which is why did I hallucinate? It's possible. You probably did say that. And the next thing he's about to say is, but I learned better. I looked into Tailwind and I was horrified by what I saw. HTMX a fad? I don't really see anyone talking. You know, I don't see anyone talking about HTMX either. But I really like the idea of HTMX. I do. Let's see. I don't want to open up more tabs. I'm already at 1, 2, 3, 4, 5, 6, 7 tabs. I started this stream wanting to learn Tokyo, and all I've done is just yap with chat about technology bullshit. I haven't actually gotten any work done, and I'm already an hour and 10 minutes into this whole thing. Oh, Hanny, you've actually been using HTMX. Okay. Is it, have you been using it in production at your job? because that would be really interesting. I'd really like to know, like, I hear good things about HTMX, and then I look at it and it's like, oh man, this HTMX shit just solves so much bullshit. But it just like Mystic, did it turn out to be a fad? Because no one's really talking about it in the outside world anymore. I'll have to look into it, and I'll look into that later. But we should table that discussion because Jesus Christ, there's so much I need to do on the docket. So Redis is designed with the primary mini Redis designed primary goal, learning Tokyo. Very well commented. We will use mini Redis directly in the tutorial. This allows us to use parts of mini Redis in the tutorial before we implement them later. At any point, you're almost a pro. You got your GitHub set up. I know you know how to fork and clone. That's awesome. That's actually really good. Figuring out like how to fork projects and how to use Git. Git is probably gonna be your best friend, because across all of programming, across no matter what field you're in, you're gonna use version control. Some kind of version control. Most people are now using GitHub. I'm a crazy person. Is this still running? I'm a crazy person, and I self-host, and I actually am now self-hosting a 4JO instance. But most people are gonna. But if you are a programmer of anything, you could be doing embedded systems where you're doing a lot of C, or a lot of Rust. If you're doing embedded systems with a lot of C, if you're doing like web development with JavaScript, CSS, HTML, if you're doing Rust, if you're doing anything, hell, if you're designing circuit boards and you're using KiCad, everyone uses Git. Everyone uses Git. So Git is probably one of the most valuable things you can learn in this space. No matter what you do, if you feel like you're programming something, you should be using Git. 4JO is, for Hanny's question, what is 4JO? If you've heard of GOGS or Gitty, 4JO is kind of the new iteration of all of that. Or the short answer is, it is a painless, self-hosted Git service. It is a GitHub. Basically, it's a Git front end. So I host a Git server basically behind me. I turned one of my old gaming desktops into a home server where I do a lot of stuff, such as especially Home Assistant, where I control the lights in my house from my phone. That's all controlled by the server that's behind me. Using Home Assistant, I use it to host this Git instance. It's my Git server, so if I do, I think it's at... No? Is it at amp? Is it maybe not at... Is it maybe just /amp? Oh, nope. Yes, okay. It is basically a sort of GitHub replacement, but it's self-hosted. And it is not only self-hosted, they are exploring the idea of federating instances. So my server, my Git server, could speak with someone else's Git server, and I could initiate pull requests. I could do, if you've ever seen federation, if you think of Twitter, there is a federated, quote unquote, Twitter. And it's not just Twitter, but it's sort of like a Twitter replacement. If you've ever heard of Mastodon, Mastodon is meant to be self-hosted, federated Twitter, where you can literally just host your own server, and not only does that server speak to all of the clients on that server, and that server will have its own users. There's other Mastodon servers. There's also Pleroma. There's other Pleroma servers and these servers can intercommunicate, so that I could exist as AMP on the Amperature Pleroma server, and I could speak to any user on the Fosstodon Pleroma Mastodon server. So yeah, there's I haven't really done much with it, mostly because like there's a part of me that gets disencouraged knowing that everyone uses GitHub. But I've always loved the idea of self-hosting as much as you can. But yes, getting back to Mystic, Git is going to be your most valuable skill. Not your absolute most valuable skill, but I would focus on Git a lot. It is going to be a very valuable tool for you, no matter what school of program, no matter like what path you go down as you're on your journey as a programmer, as a developer, as an engineer. Everyone uses Git. It is the one thing with a bullet. I don't care who you are using Git. Unless you work for Facebook, because for whatever reason Facebook uses Mercurial. Well, we don't talk about that. We don't talk about it. Behind Cloudflare tunnels, just recently Tailscale. Actually, that is the Cloudflare tunnel is actually how I'm hosting my Git servers. Is how I'm hosting git.amperature.com. If you go to git.amperature.com, it is actually a Cloudflare tunnel directly into my apartment. I probably shouldn't say that, because then if someone has figured out how to pierce the Cloudflare tunnel, they know my IP address. Whatever. I'll trust you guys. Whoever's here listening, for whatever reason. I should see something real quick. I'm very surprised. Well, yeah. It is surprising. Let's just say that it is surprising to me, some of the decisions. Let's see. What did Mickey say? Still here on your spying mission? Yeah. Okay, Mickey. Mickey's still spying on us. Okay. Let's see. There's free on your network, stealing my bandwidth. I think I'm also hosting like 2 Minecraft servers. And I tried to get a Palworld server up and running. Hang on just a second. I think I tried to get a Palworld server running, but I couldn't quite do it. Let's see, getting help. If at any point... I'm speaking so much, my throat is so dry. Hang on. Oh, it's been so long. It's been so long since I spoke this much. Oh, it's like I used to do this. Readers should already be... maybe T-Dev was right. Readers should already be familiar with Rust. Is there anyone still playing Palworld? I don't know, man. Palworld game found on Xbox Game Pass. Many updates behind the PC version. That's the rub with a lot of PC games, isn't it? Or PC games that are also on console, is that the approval process to getting your patches approved on console takes much longer than trying to get patches approved for Steam. Steam is just like, there is no process, from everything I've heard. That is also something I should put on the docket as a goal. I think part of me wants to also give a minor shot at game development. I've got an idea for a game. I just want to see if I can, right? But that's somewhere down the line. Somewhere. And I've heard so many good things about this Godot engine, Godot, that it's like that Pirate Software guy. Pirate Software, that guy says, oh, Godot is the new age Flash. It is unlocking the ability to do game development for randos. I've heard there's a lot of people use Godot and Rust. Fiddled with Godot, it's pretty nice. Maybe one of these days I'll start doing Godot streams. So, readers should already be familiar with Rust. The Rust book, an excellent resource to start with. While not required, some experience with writing networking code using the Rust standard library. Or my jaw is starting to hurt. I have not talked this much in years. Jesus Christ. It's good to be back. It is good to be back. No pre-existing knowledge of Redis is required before you get started. You should make sure that you have the Rust toolchain installed and ready to go. Check to see that Rust, that Pirate Software guy, is awesome. Absolutely amazed how his YouTube took. That's the magic of shorts, isn't it? It's just the I'm a big fan of the VTubers, of the cartoon people that also stream on both YouTube and Twitch. By the way, I'm also streaming on YouTube, much higher quality. If you're curious about that, the like once his shorts took off, like he was kind of my inspiration to really start getting back. It was Pirate Software, Primogen. Haney was not the Haney was part of that, was no small part of me thinking about getting back into streaming, because I noticed Haney was doing almost daily, basically every weekday. You're doing in the mornings. I'm not a morning person, so you don't see me very often in your stream, Haney, but just know, buddy. But yeah, Pirate Software was a big inspiration, and he's kind of making me think I want to try do game stuff. Primogen, he's really taken the idea of being a software engineer and turning that into content, video content for people. And big ups to Primogen. He actually said he's recently made the switch over to full-time content rather than working for Netflix. Oh yeah, Pirate Software is a fucking monster. Like he streams to hear him tell it, that he says that Pirate Software's stream is a full-time job, but he has two full-time jobs, in that he puts in 8 hours a day on a stream, and then he'll put in another 8 hours a day programming whatever the hell that video game is. I don't know that video game from my own pinky finger. Like I have not seen that. Like I think he calls it Heartbound. Maybe I should check it out. It feels like I'm insulting him to say it feels kind of insulting to say whatever the hell that video game, but yeah, he puts in 8 hours of stream and then 8 hours of development on Heartbound, I think is the name of his game. The big one for me that is a channel by the name of Low Level Learning. And I think I've said this early on in the stream. Low Level Learning was a big source for me to go, oh, embedded. Because Mystic, you'll know, I'm pretty sure you'll know that embedded was kind of where I got my start here. Writing that bot, writing the Twitch Beagle, where I was doing like microprocessor stuff, and I had the lights that could be controlled by chat. So that's my history. That's where I come from. That's my education, is in embedded systems. And then I see Low Level Learning come along and showing that you can do content on embedded systems in a real way. And I'm like, oh man, that's cool. Making me want to get back into it. And with Haney, it's mostly just jealousy. It's like, if that guy can do it, like I can get back into this game. Well, what if he can? He's got a wife and 2 kids. I'm single. What the hell am I doing? So I'm giving you shit, Haney. Your family's lovely. To check that Rust is installed on your computer, run the following. Hey, you know what? We have a chance to actually write code. Well, maybe not code, but we have a chance to do a command. Let's see. Rust C. Version. Hey, we have Rust installed, and it's version 1.75.0. Alright. We're done programming for the day. Let's go back to the tutorial. Uses WebSockets, so oh god, WebSockets. So I'm gonna spoil a little bit. The project I have in mind that I'm trying to learn Rust for is I want to try and do like a chat aggregation, where I pull in chat from Twitch, from YouTube, from Kick, from Discord, hell, from Rumble, from Trovo. Try to pull in chat from as many places as I can and give not only a single client that lets you see your chat as a streamer, but you can embed the chat just like I do here. This chat only has Twitch and YouTube. I would like to try... The big one I'd really like to attach is Discord. Annie, it's good to see you again too, buddy. Hope you have a good night. Thank you for the lurk, and I guess we'll talk later. Is it like Stream Ninja or something, Mystic? Because I looked into that and I really didn't like the implementation. Like, it was so wonky. Like, you have to install it as a Chrome extension, a Chrome plugin, and then the way you can embed is by you have to have the tab open. You have to have the Twitch chat tab open. You have to have the YouTube stream chat tab open. All of those, and then like the CSS wasn't. It was really it just struck me as weird. Struck me as really weird. So, let's see. So, cargo install mini Redis. Okay. So let's go back. Cargo. Install mini Redis. Crates.io. Doing a lot of compiling. I feel bad that Hanny missed the actual part where I'm actually writing and executing commands and possibly writing code. We don't know. We'll see what happens tonight. Caster Labs. Caster Labs. Caster Labs. Free widgets and alerts for multi-streams. Okay, I see Twitch. I see Trovo, YouTube. I see DLive, TikTok, and Kick. So here's the thing. Because I've seen multiple solutions out there that try to do it or claim they can do it. They all miss something that are deal breakers for me. This, right now, for one, first thing, not cross-platform. Download for Windows. Where the hell is the Linux client? I am a Linux streamer. I work on a Superior operating system that doesn't have ads in the start bar. That's the first thing I noticed. Well, no, the first thing I noticed was the big thing. I don't see Discord down here. This whole project, this whole idea is because I'm tired of here I am using primarily a Twitch chat, but I've grown not fond of Twitch as a website and as a streaming platform. I really want to move to YouTube. I think it is an actual superior platform, except for one thing. YouTube's chat is the worst thing I have ever experienced in my fucking life. It's awful. It is awful. Not just as a person who is sitting in chat and typing to the streamer, but everything around it. And it all centers on one thing. It is a polling API. You are making get and post requests to an API to get the state of chat, rather than everyone on the planet who just implements IRC or implements some kind of socket server. YouTube does it through post and get requests, and it's infuriating. Yes, why you love WebSockets, yes. So my bright idea at some point was, why are we using, like, Twitch has the probably the best chat, but really when you think of it, Discord is really the place to chat. And it should continue to be the place to chat. And Mystic, you've been in a couple streams when I was like kind of an off and on again streamer, right? You've seen me like, here I'm embedding Discord rather than embedding than YouTube. That's the goal I want to get to. I want to embed all of the chats in one window and in one embed. But I really want to direct people, as far as chat is concerned, into a Discord. Maybe that's a weird ulterior motive, but I really think chat is best served in a dedicated chat platform. And Discord is a dedicated chat platform. But I don't want to, but I now have learned I really shouldn't leave Twitch behind, leave Twitch chat behind, leave YouTube chat behind. But I want to have a dedicated chat platform that I can embed as, like, this is where you go, not only for after the stream is gone, because it was always weird to me that, like, hey, come join the Discord and chat in the Discord once the stream is over. But then once the stream starts, we all move to this other chat, which is the Twitch chat or the YouTube chat or the Kick chat. For me, that struck me as odd. So now it's like, why don't we just keep chatting in the Discord? Again, maybe I'm crazy. Maybe I'm just insane. Who knows? But yeah, okay. So, Mini Redis. And that's why I don't think I'll be using this solution here, is because I don't see Discord. Actually, that is a tiny image. Caffeine, Twitch, Trovo, Glimish. Glimish is gone, unfortunately. Well, I don't know, unfortunately. I never touched it myself. There's DLive, there's YouTube, there's Kick, there's Theta. I think like 4 or 5 of these are gone. Caffeine, I think, is gone. I think Glimish is gone. And I think Theta is gone. Well. So, let's get back to what we were doing before. So make sure that that Mini Redis was successfully installed by starting the server. Let's see. What was the command? Mini Redis server. Maybe I'm wrong. Command not found. Mini Redis server. Okay, what if we get rid of Tmux? Mini Redis server. Learn. Cargo install. Was it Redis? Mini Redis? That's interesting. Why is it not, Oh, is it sudo cargo install? Hang on. Sudo cargo install mini. Could not choose a version of cargo to run. Run rust up default stable. sudo rust up default stable. Okay. That's installing many Rust things. Okay. So then, cargo install mini Redis. So I'm installing mini Redis as root. Uh-oh. Compiling means I'm dropping frames, or not. I dropped to a really low frame rate there for a second. Hope everybody's okay. Hope everybody came back out of that storm. Let's see. So if I come out of Tmux, actually if I close that window. Hang on. I gotta grab cd dev, rust, Tmux. Where's Tmux at? Not Discord, not that, not Kick. Tmux. There we go. Ramming your PC recently, you got 128 gigs. That's my server has that. Jesus. All right, so let's re-enable Tmux. Okay, mini Redis server. Oh, I'm already up a creek. How come? Let's get back to our developer. Cargo install. Is it bin? What am I looking for? Cargo install path. Add to path. Setting correct path. Okay. I was installing this website, downloading software. Suck it. I should zoom in so that actual people with eyeballs other than mine can read. Its programming language is Rust, so I proceeded to install the package. After completion, the message prompted home user.cargo/bin. So, is it cd? Actually, yeah, cd cargo bin. Ah, okay. And it is already executable according to this. So what if we mini Redis server? And it's just gonna sit there for a second. Tell you what, while that's running, I actually have to get up and take a short bio break. So it has now been about an hour and 40 minutes into my stream. Hope everybody's doing okay. I'm just gonna get up, stretch my legs a little bit, refresh my drink. I should probably put up something. Someone on Kick said no, Somalian man. Kick is not embedded in the chat, but Somalian man, no, says maybe he does mind if I get up, unfortunately. But, unfortunately, I do need to, get up to stretch my legs a little bit. Okay, Somalian man. Anyway, I will be back very shortly. Enjoy the music while I'm gone. I'm gonna turn it up just a little bit. And I will be back. Give me like 2, 3, 4 minutes. Alright, I hope everybody got up, got stretched their legs, got some new drinks. Take a sip. Refresh yourselves. Hope everybody's feeling real good. So let's see, let's get rid of, because I am back now. It's no more be right back. I am back. So, where was I? Oh yes, apparently running a mini Redis server. What I'm doing. First, let's window. You don't get to see me moving the window because I'm just, I'm not capturing the desktop. I'm capturing. Okay, so go back over here and say. Is it print env path? Okay, so there's user local, there's sbin, there's bin, there's user bin, there's flatpaks, there's the Java bin, Perl, a lot of Perl bin, Rockham bin. Ah, okay. Yep, that does make sense. Export. Path. What is the actual? Okay, path is equal to path, and then home amp the dot cargo / bin. And then let's do printemp path. Path, not app. Okay. So then now, let's try this again. Mini Redis server. Hello. Address already in use because I'm already doing that. Okay, so let's see, mini. Let's make us a new. Serve. Oh, you know what? Because we need to do that first. Then we say mini Redis server. Awesome. We're getting somewhere. We're doing things. We're writing code. We're accomplishing tasks. What we're doing right now. Just a little further away from my face. Oh, that's right. I need to turn down the music just a touch. Music is a tad loud. I noticed that moments before you actually said it. Oh, yes. Okay. But thank you for the warning. I almost didn't notice, but I did. Good looking out, Mystic. I do appreciate that effort. Can I? Let's see. Is there a thing I can do? No. Okay. Mini Redis server. Then in a separate terminal window, try to get the key foo using mini Redis CLI, and I'll show you because I didn't have that up in a separate window, which not a separate window, in a separate pane in Tmux, because Tmux is an amazing tool. In a separate window, try to get the key foo using mini Redis CLI, and there's the command mini Redis CLI get foo. Okay, so let's go away from there, get rid of our random window over here, and let's horizontal split. Let's export our path. Mini Redis CLI get foo. And it says nil. Should it say nil is the question. You should see nil. Okay. That's it. Everything is ready to go. Go to the next page to write your first asynchronous Rust application. Nearly 2 hours into this broadcast, we're actually going to be writing Rust. How excited are we, ladies and gentlemen? Are we excited to actually be doing things and accomplishing tasks instead of just yapping about and experimenting and testing just exactly how far we can shove our thumbs up our asses? You call yourself a pro streamer now. Well, if we're measuring in dollars made, I've probably made a grand total of about. Well, no, I did get a Twitch payout once, and that was back when the Twitch payout was limited to $100. So I have made at least $100 on Twitch before. But next page, hello Tokyo. So it says, let's go into my Redis, open the cargo toml, and below dependencies, we want to put Tokyo. Okay, so what I'm going to do now, I am going to hide the window from the rest of you. I'm sure you'll miss it, but I'll be here. You get to see the programming area. So I'm just going to follow the directions, and I hope you trust. You've probably been on the site. I'll link it in Kik, and I will link it in Kik. I will link it in Kik. Is it not letting me send? It is not letting me send links in Kik, even though I am the broadcaster. Great. So I'm gonna link it in Twitch, and I'm gonna link it in YouTube. That is the current page that I'm on. You get to follow along, even though I'm not actually saying anything. Okay, so let's start by generating our new Rust app. Cargo new my Redis. Let's see. Let's go back up here. Cargo new. Oh, cargo new my Redis. Let's go into that directory. Now we say we want to open the cargo.toml. And in dependencies, we want to put the following text. And I'm just going to copy paste. So we want to say that Tokyo is a dependency, the Tokyo crate. I know they don't like the language saying libraries, but I'm going to call it a library. They call it a crate. Version 1 and features full. Not quite sure what full means to them, but you know what? Let's run with it. So we'll save that. And now we want to open main.rs. And it says print hello world, but let's do something a little different. Let's copy and paste the code. Now we're copy and pasting. You know, we're not the best engineers here. We are copy pasting, but let's see if we can copy paste in a way. Let's at least, oh, we can't do that. Okay. Insert. Hang on, I just gotta ping on Discord and I'll let him, I just wanted to, that is someone I do want to talk to. Hang on just a second. Sorry, I know I'm talking to I'm talking to someone outside of stream. Just learned about functions, arrays, and objects, etc. Oh, that's good. So we're still kind of in the beginners phase. Okay, let's see. Use mini Redis client. Can I paste? I can. Okay. So we'll save that. Unresolved import mini Redis. Use of undeclared crate or module. Mini Redis. Really? Oh, we do have to add mini Redis to the cargo toml. So mini Redis equals what version are we using? 0.4. All right, so we have that going for us. And I really like this bit down here. You see above the blue line where it's pretty much already like pre-compiling things. Okay, so we have mini Redis 0.4. What was it trying to do? Oh yeah, let's go back to not just cargo.toml, let's go back to the main. So we say client, we're setting up a client. Let's see. And we're using mini Redis, the client and the result class, or not class, the type. Let mutable client is client.connect to localhost on port 6379, and we await that. That's notable. And we are telling the program that this is an async function in main. The main function is async, although it used to... I remember it was giving me guff. Unmatched. Why does it say unmatched? Unmatched closing squirrel bracket. That's an interesting... That is really interesting. I don't know why it's giving me guff about that. But anyway. So on the page... Well, anyway, it's saying client is set hello... Set the key hello with the value world. Okay, that makes sense. Client set hello world.into. I don't know what into. I don't know what into means. String. Let's add, you know what? We can probably look that up. What does Rust string.into? From and into. Oh, we're doing Rust by example here, boys and girls. From. The from trait. I don't care about from. Into. The into trait is simply the reciprocal. Oh, well, I guess we do have to learn about from. Allows for a type to define how to create itself from another type, providing a very simple mechanism for converting between several types. From. Wait, really? Hold on. The code says into. Code is into and then nothing. So standard convert.into using into trait will typically require specification of the type to convert into, as the compiler is unable to. However, this is a small trade-off. You have implemented the from into will call it. That's okay. Using into trait. Okay. So let's go back to our Hello Tokyo. Make sure the mini Redis server is running, and it is. If you've not already installed, we did it. Now let's run the mini Redis. Okay, let's go to our browser. We have more room downstairs. We do. Okay. Let's export our path. And what was the code I was running? Cargo run. But we want to go into the mini Redis. My Redis? Yes. Cargo run. See what it says. Uh-oh, it's compiling. First of all, let's move some of the stuff. And we want to this small. Got value from something. Results some world. Okay, so So what this code is doing, first it's setting the key of hello and world. We await that, and then we get the result by saying we have our client, we tell it get, we want to get the key hello, we await, and then we print that, got value from the result, got value from the server, result is that. Okay, I think that's simple enough. We have our input, we have it in Tokio, so we know it's asynchronous because we're doing a lot of awaiting. Okay, we're getting places. We're going places and doing things and accomplishing tasks. So let's go back to our browser window and see what it's telling us about Tokio. Breaking it down. Let's take. I thought I already did, but you know what? Probably better to let them tell me what I'm trying to do. Otherwise, we're just flying blind. Take some time to go over what we just did. There isn't much code, but a lot is happening. So let mut client connect, port 6375, 6379, await. The client connect function is provided by the Redis crate, which we installed and downloaded. If you were paying attention back then. Asynchronously establishes a TCP connection with the specified remote address. Once the connection is established, a client handle is returned. Yep. That is, even though the operation is performed asynchronous, the code we write looks synchronous. And it looks synchronous probably because of that await. The only indication that the operation is asynchronous is the await operator. What is asynchronous programming? Okay. Just like I said, we're learning about asynchronicity here today. Most computer programs are executed in the same order in which they are written. The first line and then the next, da-da-da-da-da. Synchronous programming, when a program encounters an operation that cannot be completed immediately, it will block until the operation completes. It's just gonna wait. It's just gonna sit there. And you have to deal with the fact that you're waiting for the next thing to happen. For example, establishing a TCP connection. And for example, pulling down any kind of web page, pulling down, you know, I work for an app where a lot of ingest happens. If you're trying to ingest data from another application or another web service, that's what you're doing. You're doing a lot of awaiting. It requires an exchange with a peer over the network, which can take a sizable amount of time. During this time, the thread is blocked. Asynchronous programming operations that cannot complete immediately are suspended to the background. Okay, well, while we're waiting for the other guy on the other end to complete his processing of information and sending it my way, I'm gonna go do these other things over here. The thread is not blocked. Continue running other things. Once the operation completes, the task is unsuspended, continues processing from where it left off. Our example from before only has one task, so nothing happens while it's suspended, but asynchronous programs typically have many tasks, which I'm going to have many tasks on the application I'm writing. Although asynchronous programming can result in faster applications, it often results in much more complicated programming. That's a very natural thing. If you're doing one thing, you're doing one thing. If you're doing two things, you're doing more than one thing. If you're doing three things, you're doing more than one thing. And so you got to keep track of all the things that you're doing. And you got to coordinate all of the things that you're doing. Programmer is required to track all the state necessary. Oh, you know what? And he's saying exactly what I said. The programmer is required to track all the state necessary to resume work once a synchronous operation completes. Historically, this is a tedious and error-prone task. It's basically say most people are dumb as shit. Rust implements asynchronous programming through a feature called async await. Functions that perform asynchronous operations are labeled with the async keyword. In our example, the connect function is defined like this. So we have mini Redis result, we have our client, and we have Tokio Net2 socket address. Mystic, you were talking about sockets earlier, so this is probably a socket, like you were meant. Ooh, excuse me, a little burpy burp there. using the async function definition, looks like a regular synchronous function, but operates asynchronously. Rust transforms the async fn at compile time into a routine that operates asynchronously. Any calls to .await within the async function yield control back to the thread. The thread may do other work while the operation processes in the background. If this doesn't quite make sense yet, okay, although other languages implement async await too. Oh god! Rust takes a unique approach. Primarily, Rust's async operations are lazy. Lazy in bold. Don't know what that means just yet. We might learn. This results in different runtime semantics than other languages. If this doesn't quite make sense yet, don't worry. Don't worry your pretty little head. We will explore async await more throughout the guide. Async functions are called like any other Rust function. However, calling these functions does not result in the function body executing. Instead, calling async fn returns a value representing the operation. So you can't just call an async function. This is conceptually analogous to a zero-argument closure. To actually run the operation, you should use the .await operator on the return value. For example, the given program. If we want to say print, if we define an asynchronous function called say world, we print line the word world. And then in the main function, calling say world does not execute the body of say world. Now, horizontal scrolling. Okay. Calling say world does not execute say world. So we say let op equals say world. And so that's more of a pointer to a function than calling the actual function itself. And then this print line comes first. And then when we tell it to await, we await the results. The return value of an async fn is an anonymous type that implements the future trait. Future is something that's definitely something to look into. What is a future? Because I've heard a lot about futures, but I don't know too much about like the intricacies of what a future is. The async main function. The main function used to launch the application differs from the usual found in most of Rust's crates. It is an asynchronous function, and it's annotated with this stuff, Tokio main. So we're telling Tokio that this is the main function, this is what we're doing. An async function is used when we want to enter an asynchronous context. However, asynchronous functions must be executed by a runtime. That's another tab for us to look into. This runtime contains the asynchronous task scheduler, provides evented I/O, timers, and etc. The runtime does not automatically start, so the main function needs to start it. Okay, let me make sense of that to myself. The runtime contains the tasks, so it's got the task scheduler, it's got the I/O, timers, and it does all that. But the runtime doesn't start on its own, so that's why we take async main, and we are telling Tokio, the runtime, no, this is the main function, and you need to start now. Okay. The crunch Tokio main function is a macro. It transforms async function main into a synchronous function main that initializes a runtime instance and executes the async function. Okay. For example, the following, telling it Tokio main to transform this into a function main, gets transformed into function main. Let mute RT. Let the runtime be, and it's a mutable runtime too. So RT block on async, print line hello. The details of the... Wait. Okay. The details of the Tokyo runtime will be covered later. So T-Dev earlier in the chat was asking, like, what makes Tokyo special? Why wouldn't you just use async await in Rust? Looks like that may become relevant later. When depending on Tokyo for this tutorial, the full feature flag is enabled, so we turn on the full features. Tokyo has a lot of functionality. TCP, UDP, Unix sockets, timers, multiple scheduler types. Not all applications need all functionality. Unix sockets are very interesting to me. When attempting to optimize compile time or the end application footprint, the application can decide to opt into only the features it uses. Okay, so spawning. We're gonna shift gears and start working on the Redis server. Okay, let me do some quick admin work here on my end. Just checking on a couple things. Make sure everybody's okay. Everybody's nice and comfortable. Okay, yeah. Keep going from here. First, move the client's set get code from the previous section to an example file. Okay. So let's go ahead and do that. Examples. Hello, Redis. Got it. Let's get... I really need to have like a dedicated button to hide that window. So now, get out of Vim. Let's make their examples. We'll move. Is it? Hang on. Okay. We'll move source main into examples. Hello, Redis. Is it RS? Yeah, RS. I'm going to go ahead and not show you the window again, so I'm just going to link it here in chat. Twice, in fact. I'm going to link the page that I'm currently on. Create a new empty main.rs and continue. Got it. So we touch source main.rs, and we vim that. Open source main.rs. Awesome. Then create a new file and oh no. Oh. There we go. The first thing our Redis server needs to do is to accept TCP inbound connections. This is done by binding Tokyo Net TCP listener to 6379. Many of Tokyo's types are named the same as their synchronous equivalent in the Rust standard library. When it makes sense, Tokyo exposes the same APIs as standard, but using async defend. Then the sockets are accepted in a loop. Each socket is processed, then closed. For now, we will read the command, print it to standard out, and respond with an error. Okay. I'm going to go ahead and copy paste this into our Vim window here. And let's just review. So from Tokyo Net Utilities, we're grabbing TCP Listener and TCP Stream. We are grabbing connection, and we are grabbing... Oh, no. We are grabbing connection. Grabbing... Hang on. Why is it... I really need to get rid of mouse control on NeoVim. So we've got Tokyo main. We've got async main. Bind the listener to the address. So we have our listener. And we bind to port 6379. We are wait. I really need to figure out what unwrap even means. I don't know what unwrap means. Because I see that all the time in code that I'm trying to write. Then we loop this, where we let the socket and everything else is set the listener to accept, or accepting, I guess, data on the listener. We await that, so it's an asynchronous, and then we unwrap. And then we process that socket, and then we await. And then down here in the process, say there's a connection, and we connect to a new socket. Okay, hang on. The connection lets us read and write Redis frames instead of byte stream. I don't know why it decided to put frames in bold. The connection type is defined by mini Redis. If let some frame connection read frame await wrap print line. Huh? So then if I go downstairs, what does it say if I do cargo run? Could not compile previous error. Consider adding a main function. Really? Oh, did I not save this? Okay, unoptimized. Okay, thread main panicked. Oh, it did. Okay, yeah. It said it was gonna give me an error, and it gave me an error. I didn't listen, but I should have. Okay, let's go back to Let's go back to our browser. Cargo run in a separate terminal window. Okay, the output should be error on. That's interesting. So let's try that real quick. Is it examples? Okay, yeah. So cargo run example hello Redis result world. Okay. Wait, really? The sockets are accepted in a loop. Okay, that's an interesting output there. Mostly because it is telling me that the output should be, by running the example, run this accept loop. Now, I thought I was running it. So, if I open these back up, loop 6379, wait, socket, but on the browser, cargo run example hello Redis. In a separate, it's saying that it should just run, right? That's so cargo run. Like main panicked. Why would it panic like that? Address already in use. Oh, okay. So cargo run. And then if we go into my Redis, cargo run example, hello Redis. Error unimplemented. That makes sense. Go ahead and close that. And then got array, bulk, set, hello, and world. Okay, that makes more sense now. So this code actually is the main. So this is technically a Redis server, even though it only has like the one. Now accept this run loop currency. Our server has a slight problem. Besides only responding with errors, it processes inbound requests with time. When a connection is accepted, the server stays inside the accept loop block until the response is fully written to the socket. We want our Redis server to process any current requests. do this, we need to add some concurrency. Okay. Parallelism are not the same thing. Alternate between two tasks. You are working on both tasks concurrently. Working on both tasks concurrently, but not in parallel. So if you're switching back and forth and checking on each task, they're concurrent tasks, but they're not parallel tasks. Because only one is ever actually running at one time. For it to qualify as parallel, you would need two people, one dedicated to tasks. Okay. One of the advantages of using Tokio is that asynchronous code allows you to work on many tasks concurrently. Again, concurrently, not in parallel. Without having to work on them. Okay, without having to work on them in parallel using ordinary thread. Okay. In fact, Tokio can run many tasks concurrently on a single thread. To process tasks connections concurrently, a new task is spawned for each inbound connection. The connection is processed on this task. So our new accept loop comes. We take our socket. Our socket is we accept the connection, and then we await, and then we unwrap, and then we move. We spawn a new task. So we spawn a new task. Async move. I don't know what async move. Async move is. They'll probably do that later. Each inbound socket. The socket is moved to the new task and processed there. A Tokio task is an asynchronous green thread. What is green? That's something to put a pin in. You want to know what a green thread means later. They are created by passing an async block into Tokio spawn. Tokio spawn returns a join handle, which the caller may use to interact with the spawn task. The async block may have a return value. Okay. The caller may obtain the return value using the await on the join handle. Okay, so just to be sure, we're going to rewind all the way back. Where we say, in our original example of what asynchronous code means from Tokio, when we say let op equals say world, and technically say world is a function, but say world as a function isn't actually returning its own execution. The op is actually a join handle, if I'm understanding this correctly. If I'm leading you astray, I pray for your safety. So, go back into spawning. Go all the way back down here. I think this is it. Yeah. Yeah, so handle await, and the join handle, if we take a join handle and run .await on it, that's what we get back. We get back the actual value of what the function was supposed to be. Now, side note, put a pin in this. We may ask about this later and we may be curious about it. Does the await actually signal the code to execute? Or does the await merely call to grab a function, a piece of data that's already stored somewhere? That's an important question that we'll think of later. It's important to me. I don't know if it's important to you, but it's important to me. When we say .await, are we saying, okay, execute the code now? Or are we saying, I expect this code was being run already. I expect that whatever process should have been running already should be done, and await is me saying I want the data from that process. That's important to know. It is probably that. But okay. Awaiting on join handle returns a result. The first one? Okay. Future Highway, thank you for First time chatter. Hey, how you doing, Future Highway? Thank you for joining. Welcome aboard. It's actually the first. So me saying await is telling the code to execute rather than me trying to grab the data from that code. If you're right, I hope that's correct. So awaiting on join handle returns a result. When a task encounters an error during execution, the join handle will return an error, but error. This happens when the task either panics or if the task is that's what lazy means. Don't execute until I call await. Okay, yeah, that's okay. Were you listening earlier when I said it's like I don't know what lazy means? What does lazy mean? Good to know. Thank you for that insight. That's actually that was gonna bug me until we learned later. This happens when the task either return an error. This happens when the task either panics or if the task is forcefully canceled by the runtime shutting down. Okay, when the task encounters an error during execution, join handle returns an error. And this is because either panicked. Okay. Tasks are the unit of execution managed by the scheduler. Okay, so there's an outer process, we call that the scheduler, and its job is to manage tasks. And I guess the scheduler is much like an interrupt on an embedded system, because I was used to working with ARM Cortex M4. You had a I guess parent process. That's probably not the right word to use, but a parent process that would go and actually check the value here and check the value here. But rather than checking values, it is executing code, and it's doing this like in a series of events. It's like, okay, execute this until we see, I guess, an await. Execute this until we hit like some kind of stopping point. Then move on to the next task, execute that until we hit a stopping point, execute the next task until we hit a stopping point. So that's what I'm assuming the scheduler's job is. Spawning the task, submits it to the Tokio scheduler. Wait, what? Oh. Tasks are the unit of execution managed by the scheduler. In this case, it's Tokio. So we spawn the task, which spawning the task means we tell Tokio, hey, this is a task we want to do, which then ensures that the task executes when it has work to do. The spawned task may be executed on the same thread where it was spawned, or it may execute on a different runtime thread. That's actually another important question, because Tokio keeps saying that, hey, we're working in one thread. All of the documentation so far, hey, Tokio works in one thread. But now we're saying, hey, you can do a different thread if you want. Does Tokio, its library itself, have support for multi-threading, or do I need to get multi-threading from somewhere else? And then I spawn an X number of tasks inside of this other thread over there. Tasks can also be moved between threads after being spawned. Tasks in Tokio are very lightweight. Under the hood, they require only a single allocation and 64 bytes of memory. That's not much. Applications should feel free to spawn on thousands, if not millions of tasks. When you spawn a task on the Tokio runtime, its type's lifetime must be static, which is a common misconception that static always means lives forever. It's not the case. Because a value is static does not mean that you have a memory leak. I guess static would mean it lives for the lifetime of the program? That's probably a question for later. Static bound. When you spawn tasks on the Tokio runtime, its lifetime type lifetime must be static. For example, the following will not compile. We task. We have a vector array of the numerals 1, 2, and 3. Integers, I assume they are. Task spawn async. It means it can live for the rest of the lifetime of the program, and I'm guessing when you say can, you mean there's other ways to kill that. I know Rust doesn't have objects, but I'm thinking in terms of like objects. There's probably other ways to kill anything that's static. It doesn't need to. Got it. Attempting to compile this because... Okay, so the task itself, so task spawn async needs to be static. Async block may outlive the current function, but it borrows v, which is owned by the current function. Okay, so we say... Aha, okay. So we let v, and it's not... It's weird that it says it's borrowing, because I don't see the borrow marker, but okay. It's borrowing v, which is owned by the current function. Which would then mean, because I guess we're trying to give ownership to that println function, that println macro. Does v need to be static? This happens because function requires argument type to outlive static. Okay, so the part before async needs to be static. To force the async block to take ownership of v and any others, use the move keyword. Okay. Okay, this happens because by default, variables are not moved into async blocks. The v vector remains owned by the main function. Okay. The println borrows v, our v instance. The Rust compiler helpfully explains this to us and even suggests the fix. Changing line to say move will instruct the compiler to move v into the spawned task. Okay, so let's pretend in our brains, in our mind's eye, that this says async move. So this means any variable inside of the task that has been spawned is moved into that, and is moved and is now owned by that task. Hence the curly brackets. It is now a block of code. So now v, if this says async move, v is now moved, aka owned by that block of code. This happens because the default... Okay, yeah. If a single piece of data must be accessible from more than one task concurrently, then it must be shared using synchronization primitives such as arc. Okay. I'll have to look into what arc is, but obviously it's a synchronization primitive. Note that the error message talks about argument type outliving the static lifetime. This terminology can be rather confusing because static lifetime lasts until the end of the program. So if it outlives it, don't you have a memory leak? Not necessarily. After what we know we can kill it, or at least, like, I guess lifetime kill is not the worst wording. The explanation is that it is the type, not the value, must outlive static. Okay. And the value may be destroyed before its type is no longer valid. When we say that a value is static, when we say that a value has a static lifetime, all that means is that it would not be incorrect to keep that value around forever. This is important because the compiler is unable to reason about how long a newly spawned task stays around. We have to make sure the task is allowed to live forever. Allowed to live forever, okay. So that Tokyo can make the task run as long as it needs to. The article that the info box links earlier uses the terminology bounded by static rather than its type outlives static or the value is static to refer to static. All mean the same thing, but are different from annotated with static. Okay. Task spawn by Tokyo must implement send. I guess it's a function of some kind. This allows Tokyo runtime to move the tasks between threads while they are suspended at a dot await. Tasks are send when all data that is held across await calls is. This is weird language, because in my head it's like, I guess tasks are sent, because you gotta put it in past tense. Is send in this sentence, is send a verb or a noun? I guess it's a noun because it's capitalized, therefore it's probably some kind of type. A task is a type of send. Noun? Noun. Okay, thank you. God. It's... Tasks are a type. The name of the trait called send. Okay. The name of the trait called send. Tasks are a send trait when all data that is held across .await calls is also a send trait. Okay, this is a bit subtle. No kidding. When .await is called, the task yields back to the scheduler. It says, okay, I'm done. Well, I'm either done or I'm waiting. The next time the task is executed, it resumes from the point it last yielded. To make this work, so you call await. Await goes back to Tokyo and says, hey, I'm done-ish here. So you can go do other things, go to the next task. And so the scheduler moves on to the next task until the next time it sees .await. The next time the task is the next time this task is executed, it goes from that .await. It's like, okay, I'm ready to go, move forward. More data. It resumes from the point it last yielded. To make this work, all state that is used after .await must be saved by the task. If the state is a send trait, i.e. it can be moved across threads. So, okay, because it's, okay, it is a send trait, aka it can be sent. A task can be sent to other okay, I think I'm getting it. That's why you're calling it send. If the state is a send type, a send trait, it can be moved across threads, then the task itself can be moved across threads. Conversely, if the state is not a send trait, then neither is task. Okay. My brain is kind of bleeding right now. For example, this works. Okay. Tokyo task yield now. RC. I'm not sure what the RC library does. I'm embarrassed. RC new scope forces are. What is RC? Hang on. Rust RC. Single threaded reference counting pointer. Reference counted. Oh man, we're already in language I'm not familiar with. Shit. Inherent methods of RC are associated functions. This all looks like it's like it's a pointer, maybe? So we spawn an async. The scope forces RC to drop before await. Okay. So we create an RC. We say RC new hello. And then we print that. And then by the time we exit, RC no longer exists. In fact, that's what it says right here. RC is no longer used. It is not persisted when the task yields to the scheduler. So Tokyo doesn't know RC even exists. Doesn't know that RC here, this RC, it can't move that RC. RC is not send is the important thing to know here. Okay. So since this is dropped, it's part of, but it is part of state because it is data. But then it's ejected, it is killed once it gets out of this block. Okay, this works, but this does not. Tokyo task yield now. Standard RC. Spawn the task. We say, hey, we'll let RC. We instantiate this instance of an RC. We'll new hello. And so it's used after await. We say yield now dot await. Is there an explanation of what yield now does other than yielding now? Okay. Yield now dot await, and then we print attempt to compile. Future cannot be sent between threads safely. Future created by async block is not send. Future plus send static. Future is not send as this value is across and away. Okay. So then we need to find a way to make RC a send, I guess. So we store the state, we store all the data inside of something. I don't know what yet. I guess it's going to teach me later that we will store. We would store or move RC into its own state, like structure or trait. Store values. We will now implement the process function. Oh, we're back into actual things that we run on in our environment. It is getting late, and I'm kind of running on. I think I can go for another 20 minutes, and we'll get to the end of this here. We will now implement the process function to handle incoming commands. We'll use a hash map to store values. Set commands will insert into the hash map. Get values will load them. Use a loop to accept more than one command per connection. Okay. So let's just copy all of this. Let's go back to our dev environment. Go back up here. We paste? We can paste. Wait, I don't think that's pasting. That is not pasting. Okay. Let's copy again. Insert paste. That's what we're looking for. Okay, we'll save all of that. So let's review a little bit before we actually run anything. So mini Redis command. Stuff gets set. Selection task map. Okay, so we have a hash map is used to store the data. Let mutable DB for database. Hash map new. So we instantiate a new hash map. We create the connection to mini Redis. Where is socket? Oh, this is a process, so you're actually giving it an input. Got it. It's not main just yet. While we use read frame to receive a command from the connection. So connection, read frame, let response, match the command from frame. We unwrap that. The value is stored as a vector of 8-bit values, or an 8-bit. The value is stored as a vector of 8-bit unsigned integers. Are we only? I guess we're only storing 8-bit unsigned integers. So db insert command key to string, command value to vector. Okay. And then we frame. I need to review what frames are. I'm already like, maybe I do need to review a little bit more of the Rust book and the Rust basics. So the set command. Okay. So here's the set command, so we actually store the value. The get command, if let some value, and we get the key from that command. Frame bulk expects data. Hang on. So expects data to be one of type bytes. This will be covered later. For now, this is converted using into. Okay. Oh. So the vector, a borrowed vector of unsigned 8-bit values. Convert it to bytes because what is 8 bits but a byte? Okay, but bytes is a type inside of Rust, a specific type that has its own definitions and things implemented for it. Okay. Frame bulk value clone into. So we clone the value and we convert it into bytes. And if nothing else, we try to get the value using its key and some, so then we clone it into. Oh, nope. That will be covered later. Okay. If it's not there, then the frame is null. And otherwise, if the command is anything other than get or set, we kernel panic. Because it is unimplemented. And then we write the response to the client, we write the frame, and response. Is there a write frame? Not found in create my Redis. Oh, was I not supposed to delete that? Uh-oh. Hang on. Okay, so there's async main. Whoops. So let's delete that. And then let's copy this. Oh, actually. Copy that. Down here, paste. No, okay. Any Redis connection frame. Okay, that's fine. And then inside, actually, let's just go ahead and delete the process function entirely, and then copy the process function from the web page. And then paste it here. I think that's what we're doing. Cargo check. Looks like Cargo's happy with it. All right, so now it is telling us to run the server. Cargo run. Then we cargo run example. Hello, Redis. Awesome, and got the value from the server that says result sum. Bits that just say world. We can now get and set values, but there is a problem. In fact, I should probably have the web page back up on the screen for you guys to read along with me. We can now get and set values, but there is a problem. Values are not shared between connections. If another socket connects and tries to get the hello key, it will not find anything. In the next section, we will implement persisting data for all sockets. I think that's actually probably a good spot to call it for now. I think a good like 2 3/4, 2 hour 45-minute stream, probably a good place to kind of sort of just end off on. I think that's a good. I know we haven't really gotten much in the way of far. We've only done Hello Tokyo and kind of understood what spawning tasks even means. But I do want to thank everybody for stopping by. I'm going to go ahead and link a couple places in chat. If you want to stop by my personal Discord server, you can just go to discord.amperature.com. I want to try and rebuild a little bit of an engineering community that we had going before. I also have, since everybody seems to be here from Twitch rather than YouTube, I also can currently stream to both YouTube. I'll link my YouTube channel there, and I also stream from Kick, or stream to Kick, I should say. Kick.com/ I think it's /Amperature. Hang on. Kick.com/Amperature. Is that my URL there? It is. Okay, yes. So those are very relevant links to go by now. I'm gonna go ahead and actually, let's see. I'm gonna turn off random window. I'm just gonna explore a little bit on Twitch and see, is this else? I'm either going to be probably raiding an Eternal Enigma, a good friend of my own stream, even though he is not an engineer, not a software guy. Software and game development. Let's see who's live over there. Let's see. Viewer. So we have let's see, JD does dev. Let's see what this guy's doing. Who's JD does dev? Seems like he's doing Godot. Alright, I think I'll send you guys over, everybody on Twitch. Let's do a raid. Gave you a follow on Kick, and I think you already gave me a follow on the YouTube, so that's good. So yeah, I do think I want to try. Let's go back to it, like an ending. Is it stream ending? Did I not? Dev, I'm gonna copy the chat. Oh god.